This is exercise 919. In this, they talk about a poll where they asked 1,012 U.S. adults what they do with the milk in the bowl after they've eaten the cereal. They say that 67% said that they drink it. Then they say that suppose that 70% actually drink it. So the 70 is our P. P is 0.7. So our sample proportion, our P hat, is 0.67. And just so we know, our sample size is 1,012. So, A says, find the mean and standard deviation of the proportion P hat of the sample who say they drink the cereal milk. Well, remember our mean for this is just P, so 0.7. And that's the mu of P hat. To find the standard deviation of P hat, we're going to do the square root of P times 1 minus P all over N. So that's the square root of 0.7 times 0.3 all over 1,012. So that gives you 0.0144. So B says, explain why you can use the formula for standard deviation. Remember, the formula for standard deviation comes from the fact that the population has to be greater than or equal to 10n. In this case, that means the population has to be bigger than 10,120. There are definitely more than 10,120 adults in the U.S., so check on that one. Part C says to see if we can use the normal approximation. Remember what the reason we can use the normal approximation is n times p would have to be bigger than 10, and n times 1 minus p would have to be bigger than 10. Well, that's 0.7 times 1,012 definitely works in this one, and even 30% of 1,012 works as well. So it does work in this case. So D asks you to find the probability that obtaining a sample of 1,012 adults in which 67% of fewer say they drink cereal milk. We need to find that probability. So we're going to find the probability that we would find something that extreme or more extreme. So the probability that P hat is less than or equal to 0.67. We draw our graph. That's a really bad graph, but remember, it doesn't really matter a whole lot. We just want to put a 0.7 here and 0.67, and we're finding less than that. So to do that, we would do normal CDF 0.67, 0.7, and 0.0144. And when we do that, we get a probability of 0.0188. So that means there is a 1.88% chance of getting a p hat of 0.67 or less if the true proportion is 0.7. So that means it's pretty unusual because that means a very small chance that we would get that answer. So E says, what sample size would have to be required to reduce the standard deviation to 1/2? Now remember, the standard deviation is the square root of P times 1 minus P over N. So in order to get half as much, right, we would have to change this, because the square root, we would have to have 4 times as many, right? Because in order to get the 1/2 here, we'd have to take the square root of something in here, so that means that we have to take 4 times as many. So we would need 4,048 adults. Finally, part F says, if we had done 1,012 teenagers instead of 1,012 adults, we think this sample portion would have been greater than, equal to, or less than 0.67. Since teenagers seem to drink more milk than adults do, it would probably be greater than. .67. And that's exercise 19.